Welcome friends. In previous lecture we have seen and studied how to find the minimum reduction possible in single pass of the rolling operation, and we were discussing about the initial final velocities and slip which will occur due to the variation in the entry point or the entry plane, velocity at the exit plane and velocity at the neutral plane. I will revise last 2-3 slides so you will get the concept properly. Here we have seen that this dotted line is nothing but blue dotted line is nothing but the entry plane, which is perpendicular to this black board you can see. So the all these three dotted lines are again you can see that these are perpendicular to this black screen or the blackboard. So shown by dotted lines. Here the entry plane, at the entry plane the velocity of the plate will be lesser than at the exit plane. It is very similar to the concept of fluid mechanics or FM. If it is a nozzle like structure, here you can see as there is a flow of material, this metal is flowing in this direction, then the volume or velocity, let us say volume will be same, mass flow rate is constant because here the velocity at this point will be lesser and the velocity at this point or exit will be greater. Similarly here also happen because this shape is like nozzle or throttle you can see. So what will be the effect on the rolling process? As the velocity of this roll is constant Vr given by pi dn by 60. So because of this difference in the velocity of the sheet, there will be slipping. Slipping will occur between these surfaces of the plate and roller, and their slip will be different because difference in these two velocities at before the neutral plane will be another, whereas difference in the velocity of roller and plate will be different after the neutral plane near up to the exit plane, because velocity at the exit plane will be higher, and whereas velocity of the plate at the inlet or entry plane will be lower than the roller velocity. And in comparison to these two, we will derive equations or get the values of what I can say percentage slip. Velocity of sheet is lesser than the velocity of roller, as I have told before the neutral plane. It is written over here, and again after neutral plane velocity of sheet will be greater than the velocity of roller. Now at the neutral plane, here you can say the velocity of sheet and roller will become equal, as this velocity of sheet is gradually increasing at particular point or plane. It will become, and that plane is called the neutral plane. So Vi is equal to Vo is equal to Vr is equal to pi dn by 60 at that particular plane, neutral plane. So from here we can find the backward slip and forward slip. The forward force before the what I can say neutral plane will be the advantageous. We will see in next figure. First we will define the backward slip. It will be Vr minus Vi, as Vr is greater than Vi with respect to the Vr. Here also we will divide it with here Vr because we are finding it with respect to velocity of the roller. So backward slip is Vr minus Vi by Vr into 100. Similarly, forward slip will be Vo minus Vr divided by Vr into 100. So we'll solve one example. if we have given the final thickness is the two-third of the initial thickness of the plate or sheet, and roll diameter is 500 mm and initial velocity is the 10 mm. Determine the exit velocity of strip if strip widens by 2%. Here the width is not kept constant. So we are getting B2 is equal to 1.02 times B1. We have to find the velocity. Determine the velocity of strip. Any inlet velocity or entry velocity is given. That means we have to find the exit velocity. So what we will do, we will know the relation that A1 V1 is equal to A2 V2 because mass flow rate is constant. So volume which is entering at the inlet entry plane will be same, and from that we can derive this or get this relation A1 V1 is equal to A2 V2. We will put the value of A. Excuse me. A will be this area, shaded area, right? Area. So it will be h into the width, height into the width, A1 into B1 into V1, right, is equal to, h1 into B1 into V1. A is the h1 into A1 equal to h2 into B2 into V2. So as we know that height is two-thirds of the initial height. That means we are getting a reduced height at the exit. So this B will be cancelled as we have kept B2 is equal to 1.02 times B1. From here we are getting the exit velocity. Just in one formula we got the answer. This concept I was talking about in the last lecture, which I want to explain you. Here you can see if this below portion on the surface on which this block is kept, let us say it is fixed and not moving, stationary. If we will give some velocity to this block having mass m, let us say velocity is equal to 10 meter per second, then the frictional forces will be like this. The frictional force on the block will be in this direction, whereas on the neutral surface or the stationary surface will be in this direction. That is opposite to the frictional force of the block. When it is stationary, it will be balanced because both these forces will be equal. Now we will see if the this surface on which the block is kept is moving with velocity 20 meter per second square, 20 meter per second square. That means greater than the velocity of the block. So what will be happen? There will be relative motion, and this surface will move forward to this block. So what will happen now? There will be a relative motion, and now the frictional force on the surface, because surface is moving in this direction forward to the block, the frictional force will be in this direction, opposite direction, and on the block frictional force will be in this direction. For simplicity, I will give one more example. Let us say this block is stationary and only the surface is moving in this direction with 20 meter per second. So again, same frictional forces, direction of friction forces you will get, because only this surface is moving in this direction. So the frictional force on it will be in this direction, whereas on the block it will be in this direction. So we will use this concept in our roller, where there will be difference in velocities before the what can I say, neutral plane. What is the difference in the velocity after the neutral plane. So in the next figure you can see this will be the situation. Before the neutral plane, such type of frictional force will be there in this direction on the strip. This force is on the strip, and on the roller it will be in this direction, whereas after neutral plane F2 will be acting in opposite direction. For self rolling or without any external force, if you want to do this rolling operation, for that condition F1 should be greater than F2. That means for successful rolling process. So now I think it is clear to you how this slip will occur and how it will be different in forward and backward direction. Important note is that frictional or friction force is advantageous before neutral plane. This F1 force is advantageous because it is moving the plate in this direction towards the right side, let us say, of this screen, in this direction. Okay, and whereas this F2 is opposing, so it is not advantageous. After that means which is force after the neutral plane. Now you can see that this velocity of the roller is we will get after drawing a tangent to this contact point. Let us say here is a contact of a roller and the plate and the exit plane. Then this velocity will be same at every point, but the plate velocities will be different at different points. So our intention is to get the power, rolling power, or the power required for the rolling operation. So what we will do, we will get power from this formula 2 pi n t by 60. For that we need T. T is the torque. Let us say force is acting in this direction. Here you can see in this direction, downward direction on the plate. So this force into this much distance from the center, we will get the force into distance as a torque. For that we will need this distance AC. So we will find this AC from by using the trigonometric formula. The same figure I have drawn here. Here you can see this distance CB is very small as compared to this all distance A, O. Here will be O, point O. Here. So I'll use a theorem. You know that distance AC into distance A dash C will be equal to distance OC into CB. This is from the theorem which you may have studied in class 8, 9 or 10th. By this, you know that this distance AC and A dash C are same. So we are taking square of it. OC is twice r minus delta h by 2 because this distance is delta h. You can see is very small as compared to all these distances. Because why I am repeating this distance is small, we are going to neglect it here in this step. Twice r minus delta h. This value is the delta h from this plate to this BC. Because this complete value is r. So from O to C, from O to C is capital R minus this CB or BC, that is delta H. Twice R minus delta H. Okay. So OC distance we have worked. By solving this, what we will get? AC is equal to R into delta H. Right? Where here we are neglecting and here not neglecting because delta H is already a small quantity, small value. And if we will again take square of it, that means small quantity is multiplied with again small quantity. Let us say this value is 0.1. 0.1 into 0.2 will be again 0.001. It will be so small so that we can neglect this value. but we are keeping this value as it is. So R into delta H. Here we are getting AC is equal to under root R into delta H. For AC, you can even also use this formula R into sine theta. If necessary, if the, let us say, some values we don't have from given in the numerical, then only you should use this. If possible, always use this formula. AC is equal to R sine theta. From this is the hypotenuse, this is the right angle triangle, this is the right angle theta, opposite upon adjacent, that is R sine theta. AC from the trigonometric formula for sine theta. So we have got this AC. Now we will multiply this AC into this distance into the force acting by the roller on the sheet. Force into AC. We will find the torque. We will get the torque. Before that, how to get the force? Force will be acting in this direction. Let us say roller is acting at this middle point of the sheet. So you know that basically the force will be acting on this curved surface. But as I have told you in the figure shown you, this distance is very similar to, here I will show you in the time. This, there is no large difference in these values, as this curvature will be very large, or the radius of curvature, or the radius of this curved portion will be very high. So we can put AB equal to AC. So that is we are going to do here. We have nested AB. We will consider this area, projected area, this hash portion you can see for our calculation. AC into width we will take as a projected area. Now if you got this area, then for getting force, you know that force is the stress into area. Stress into projected area, that is W into R sine theta. AC is the R sine theta we have recently found from the last slide. So here we have got force and AC, you know, by multiplying those. This is the distance complete AC, and force will be acting at the middle. So half of the AC, actually half of the AC we will multiply with the force F to get the torque. Here we have got the torque. AC you can put is equal to R sine theta. Right, AC you know that we have already defined R sine theta, or under root R into delta H. Value for AC here it is. AC can be put equal to R sine theta or under root R delta H. But this value is little bit lesser accurate than this R sine theta, because here you are neglecting this portion. It will not affect so much, but if you are solving for ESE, engineering services, you should use this value. In GATE there will be no such difference. It will be considerable. So in this way we have got the torque value. Now power for single roller will be you know that pi d, sorry, 2, here we have find it, the formula for power 2 pi nt by 60. Don't confuse with this 2. Why I am showing you? Because again power for 2 rollers will be twice of this. So 2 into 2, 4 pi nt by 60 it will be. Or you can just first find out power P and multiply it with 2. Here it is given. Rolling power, or power in rolling process, that is for both rollers, will be twice P. So we will solve one or two numericals on this. We have given H1 initial height or thickness is equal to 20 mm, final thickness 18 mm, then the RPM of roll is equal to 10 RPM, width of the plate is 100 mm, roll diameter 250 mm, and the stress given is equal to 300 megapascal. We want to find the power. Use this formula for delta H here to get the value of theta, because we want AC value. You know that AC is equal to R sin theta. Instead of AC is equal to under root R delta H, you should use this formula for exact or accurate results. So from here we will get the AC value. It is getting 22.33 mm. We'll get the value of projected area again. Here AP. It is that is nothing but the width into the what I can say in the figure. I will show like this. This was our projected area. This was the AC. Width into AC. We will get his AP, projected area. By using formula for force, with the help of the stress value, stress into projected area, we will get the force. This will be newtons. So we'll use this to find the torque. Torque is a force into distance A. A is nothing but the half of the AC. Putting the values, we will get the torque in Newton meter, 7482.21 Newton meters. Now we will find 2 pi nt by 60 or 4 pi nt by 60 directly you can use to avoid the calculation or reduce the calculation. Here we are getting power for single roll, and for 2 rollers it will be twice of the P, which is 15.67 kilowatts. Second question is, width is given equal to 120 mm. Diameter of roll given equal to 300 mm. Final VO, final velocity is 30 mm per, meter per minute, and H1, that is initial height 8 mm, final height is 7.2 mm, stress value given 200 megapascal. We want to find the roller power for the rolling process, that is for both the rolls. I have already told you, for getting correct answer, use AC is equal to R sin theta instead of AC is equal to under root R delta H. So delta H we have got. Similarly, in the last numerical, same procedure is here. Theta, after we got the AC, then we find out the projected area by multiplying AC with the width. Finally, we are getting force value in newtons. We will get value for torque by multiplying this force into the distance AC by 2, that is A, small a. Here we have got the torque value in Newton meters. Power we will get from this formula, that is 2 pi nt by 60. Now we have not given the value for N, so we will find it from the mass flow rate, constant mass flow rate formula, that is A1 V1 is equal to A2 V2. Area is H1 into W1 into V1. V1 we have WW will be cancelled. Width is same because nothing is mentioned about width, so we will take it as constant. H1 is 8, H2 is 7.2. Vi we will get from this formula as we have given the V2. Now from V1, Vi and V2 we will find the average velocity. We will consider that the velocity of roller is average velocity of the initial and final. So here we are getting the roll velocity meter per minute. We will convert it into the RPM, pi dn by 6, only pi dn, because this is in minutes. So here we are getting N in RPM is equal to 30.23 RPMs. We will put this value of N into 2 pi nt by 60, that is formula for power. From here we are getting the value for power. We will multiply this value of power with 2 to get the power for complete rolling operation, that is for both the rollers. This was all about the rolling process. We have completed almost all the things. If you have any doubt, you can write in comment box. Thank you for watching this video. And for getting such videos in future, don't forget to like, share and subscribe this channel. Signing off for the day.